Yeah. So now, if I go for the next program with a similar kinds of concept, but let's work on something called as a grocery store. In a grocery store, what we can understand. So we have a lot of flexibility on what we want and how we want. Means on a typical grocery store, we have what is the rice or wheat, costs only. Generally, quantity is not fixed, but the quantity we should ask in runtime and we do it, right? So till now, we are working with constant values, but we never worked on the runtime values. So in terms of these things, first we need to work means we need to implement the algorithm. In the algorithm, first we need to assign these variables and get the costs. To get the costs, the same thing, what we did till now, we try to get the costs. Cost of rice equal 10, cost of wheat is equal to 34. Now, the next thing, we need to get the quantities. Were not given the quantities, so we should ask these quantities in runtime. So how do you get the values in runtime? There is a new function called as input. So what is this input? How it will work? So input is used to get the values in runtime. So there used to be two kinds of inputs in Python 2. So there used to be something called as a raw input and input. So there is a difference. But in Python 3, there is only one input. But the input will not treat everything like a individual data types, but it will treat everything like a string. So what is the reason? I will tell shortly. So we will see how it actually works. So if you want to get the quantity of items, say I want to get the quantity of rice. If I say like input, this is another built-in function. And if I ask to get the quantity of it, say I'm printing the quantity of rice equal to whatever is given. Now, if I run this program, so Python d so and so, you can notice that it's not showing anything, but it is expecting some output. If I give an enter, what it is showing? It is an empty string and it is a type string. So again, if you ask, the same thing happens because it is not showing anything. Now, this input function optionally can take any kind of string. Means within quotes, if you give something, it will first print that and ask the value in runtime. If I repeat again, this time it is showing. Now it is easy for humans to understand. Okay, I need to give the quantity of rice. If I give say some 3, it is saying that it is of type string. If I give like, so any data type, if you give Python, so d so and so, if I give like 2.3, it will say string. If I say like a true, which is a boolean, then it says string. If I do like, so some big number, then also like this. And if I execute and give a none, then also it is string. Did you observe that in all the cases, it is treating like a string only? So that's the most important point here. So why it is treating every time like a string only? The reason being, so input takes anything like a string. Why, sir, like that? Means, so to avoid any kind of attacks called as, so to avoid injection attacks. Injection attacks means sometimes if you are processing any number and storing it like an integer, if you give a none, it should store like a none, like that. Means it would process it first, right? And then it will store. But what if injection attacks and others means, so some hackers will give the code to execute. What if they give a code to delete a particular user or get the passwords of a Linux box? So to avoid that, it will give like everything like a string. Then you can do validations and you can do. So due to that, everything is treated like a string. But in this case, quantity generally they give like a integers. So we need to convert to an integer. So I told that there are type converters if you want to convert anything. So if I convert now things will be clear. If I execute and give like 2, it works. Now there is a problem at a then solution also. 2 means it should be like an integer only. But what if I give 2.3? So integer doesn't work there. But generally it's a common sense. So integers don't be like a floating point, right? So we can work. Next, in the next chapters, you learn about exception handling, where you can handle these things. In the same fashion, for the wheat also, I can process in the same logic. I can place what is the quantity of wheat and get it. Here and Python. This is 2 kgs, that is 3 kgs. It's working. And see here, every time I'm converting to quantity, but I'm not printing right here. So if I print it, now you can see both the things coming. So this is 2 kgs, this is 3 kgs. Fine. And also, first you are taking the input and then again using the variable you are converting. Generally, in real time, people will not write like 2 statements like this, but they try to write all of that in a single statement. Hope you understood the difference. First, you are taking to an input and storing in a string, then converting that to integer. This time you are doing both in one step. So generally, you will see in real time people working like that. Now, the process is simple. Again, the remaining process, calculating the selling price and all these things is the same story. You got the both quantities. You can get the selling price by multiplying cost and quantity. So selling price of wheat, and you can combine them. So the process is simple again. You execute, you got it right. So 2 kgs, 3 kgs, you got the final result. But if you don't do the conversion, sometimes problems will be faced by people like you. What people do is like, if I don't convert this to a string, okay? So see here, in Python, we can multiply a string with an integer. Due to that, if I don't convert, see what will happen. If I give the same 2 and 3, you get value like this. So the most common problem beginners like you will do is like this. Python supports something called a string repetition operation. Generally, if I give 2 into 3, I'll get like this. But what if I take the same 2, like an input, like a string, and into 3, I get like 222. Don't think like it is 222, but think like it is a string repetition operation. In Python, if you have a string, say like, Uday, and if I say like into 8, 8 times it will repeat. So any string, it can repeat like that. So that is the common problem you will face whenever you're using a input function. Now, in this class, you learned about in this program, another built-in function called as input. So like this. In the same fashion, so you have one more thing called as about, say, savings bank. We can take the example of a savings bank. In a typical savings bank, what we can do? E. So in a savings bank, we can have all the values stored. So maybe I will take this as an assignment for you. You can do it. So take an initial balance and then create a variable with this initial value and deposit some values and credit, salary, and online purchase you have done. Means you need to subtract, house rent, subtract, finally display. It's a very simple program. You need to take a variable called as balance and do all the plus or minus and give the result. So take this as an assignment and you can work. And similarly, if I go for the case of a bank loan, so bank loan is another good example to show. Say F underscore bank loan. In the case of a bank loan, what it does? So generally there are two types of, interest, right? One is simple interest and other one is compound interest. Simple interest, if you want to understand how it works, so if you still don't know, you can go to this link. It can help you better. So you can follow this link. It can help you better to understand. Yeah. In terms of how we calculate simple interest work, you can give some values and check it. So you need to implement this formula and this value. Means you need to take some value, means the amount, rate of interest, and loan duration, and you need to calculate the final values. So if you want me to implement, It's a very simple example to say. So initially, I can hard code these values to show you how things works. So if I can take the example of, say, see in this example, the borrowed amount, rate of interest, and loan duration. I have three values. Now, for these three values, I need to implement to these values. So how can I implement this one? So formula, you understood this formula, how I'm implementing C. So this is like amount is equal to principal. So principal are like the borrowed amount into, it is saying like 1 plus R means like rate of interest into, so T is like, duration. So duration is like loan duration, right? So 10 years. So if you are given in months, you need to convert to years. That's one thing. So this formula I converted and placed into a programmatically. So now instead of amount, I can make it like a payable amount or something. It's easy to remember. So payable amount means at the end of the term, we need to pay the payable amount minus the borrowed amount. So this would be the interest, right? So this is what the interest you calculated. Now, if you want to display everything individually, the principal, so rate of interest, loan duration, all those things I'm displaying. So clear screen, clear, and Python, F so and so. Now, did you see? For these given values, did you see I wrote an underscore? Just for me to understand. But it take like 10,000 only. Now, instead of hard coding these values, you can take these values in runtime also. But if you want to take these values in runtime, so how do I do? So take the same values. Instead of that, we can convert that and observe carefully which one we should take in what way. Say like I'm taking, not everything I'm taking like an integer. Rate of interest generally will be floating point value only. So int has a limitation that it works only with integers. It cannot work with floats. So if you want to have a floating point values, you need to write float only. And then I'm dividing by 100, you see. Now, if I execute, will it take? Yeah, I took the hard coding values. And again, it is asking your values. You gave like, 100, 10, something. So if I comment it and run this time clearly and Python, F so and so. Now give the same 10,000. So 10,000. And if I say 8.3, and if I say years as 10 years, now you got the same answers like previous. This is how we can get the runtime values and others. So this is what we have learned how to implement a formula into a program. Next, going further, a small assignment for you is like, as I implemented this simple interest, there is another thing called as compound interest. Just go through that link, help yourself and implement that. So that is another assignment for you. Now, during this process, we learned about the concept of conversions, means the type conversions, how they work, how they can help us. So if I see here, G, type conversions. Type conversions means you can understand that till now I told different kinds of type conversions are there. So be it like, integers, strings, all of that. Now, first tell me what are the various data types that we have till now? Can someone help me? Int, float we have, long is not there in Python 3. So then what we have? None. We have like
Boolean,
yes, Boolean. Is there anything else which I missed? So
complex,
complex. Yeah, complex. So like this. So these were the basic data types. But if you go further, there are something called as data structures. But fine. Within these things, we need to convert. Among these things, you know that int, float, complex, Boolean, all four of integer family. we can integer family, but they are different data types. We can convert from one to another like that. And also we have string and converting that to the other type. Now, for converting these things, we have different things. So there are two types, type conversions and format converters. Means within integer, there are different formats. So base 10 is decimal integers, and like binary integers, base 2, hexadecimal, octal. So like this, right? These are all not different data types, but different formats for the same number or representations for the same number. Whereas float is a different data type, string is a different data type. For converting to a float, float function, converting to a string, string function, but for converting to these representations, corresponding things. It's very easy. So, so we will see how do you convert from one format to the another and how to work. So to understand this, we can think about, rather than going with this kind of function, let's go with a .ipynb. Okay, fine. So what I can do, I would like rename. First, I created like a Python ipynb. I'm converting. Sir, we cannot open now, right? So it is saying that I cannot open it. So can you do it again? There is something in a you can place like two hashes and you can convert this also like an ipynb. That's what they say, two hashes. But that is okay. You can leave about it and you can come again. So this is a very simple way of doing. So if I do, instead of like this, I can specify that type conversions, what's all things I want to do and do. You see? So these are the various data types I told. Now I want to work. So each type I can do and see. If I say like, number one, say like, number is equal to like this. It's of type Python, it works. I need not go to the interactive mode. So because it's itself as an interactive mode. Now, if I want to convert that to a floating point value, you see what will happen? I can use the float built-in function. I can convert. Even if it is an integer, it will be 12.0 like that. And similarly, what if I want to convert an integer to a string? I can use string built-in function. Similarly, what if I want to convert a floating point value to an integer or a string? You see the difference. If I'm converting to a floating point to an integer, then the truncation happens. Truncation means I told cut. It's not like rounding. No matter 3.1 or 3.9, it will be 3 only. Whereas if I convert to a string, did you see it is coming as it is? So that's the difference. Similarly, assume that you have a string. So if you want to convert anything from a string to a different data type, not everything is possible. If I try to convert a string to an integer, as it is like an integer, we can convert. If there are white spaces also, it can convert. But what if you give something like this? Is it possible? So here it is 23. After 23, you have white space. That is fine. But between 2 and 3, if there is a space, how can it understand whether it is 23 or 2.3 or what, 2 or 3? You don't know. So these were the limitations that you should be aware. And similarly, if you give something like this too, no, it makes no sense, right? So it cannot understand that also. So for every converter, there are limitations also that as a developer, we should understand. Similarly, if you understand this one, this is genuine. It is 12.34. It's a genuine floating point value. But a integer cannot convert even a floating point value. So that is the reason in the previous example, when I'm taking an interest rate, I took like a float. So that is a limitation. Now, next, if you have a strings and if you want to convert to a float, float is something interesting. It works better. Even if you have 23 or like 23.24 or 23 point dot, like this also it will convert. Or you can have like, something like this. Say 23 point, I can have like a white space So, or anything, it works. If you have like after 23 a white space, that also it works perfectly. But between that, if you give, again, it also cannot do. Or if you write something like this, say 2 space 3 dot, do you think like it will process the first one or second one? It is confused. So then it throws an error. And observe carefully every time it is throwing an error. What is the error? In almost all the cases, what are the error is? Floating point value error only, right? Slowly you'll understand which error, which classification will come at what time. Next, using this floating point value, this is very interesting. Using floating point value, we can do further more things. If we just do like a float, observe carefully. If I just do like a float, I can generate a floating point value. I'm doing like this such that you will learn all it one shot. But if you want, you can execute individually. If I do like a plus 1.23, or generally if you're reading from a file or something, you can get a slash and write or white spaces before and after. Any white spaces we call. So those can be removed. And if I give like an exponential format, it can read and understand. Exponential capitals, it can read and understand. And this is most important. Whenever you are working, sometimes we need to create an infinite values. So we can go like this. Plus infinity, negative infinity, like this. So the beauty I will tell. So if I execute, only it will tell the last value. So this is one thing, right? If you have like a plus infinity, if I have a plus infinity, it will say plus inf, plus inf. If execute, positive infinity. So not every time we should do like this only. What if I give plus inf? This is a small letters, right? So then also it will treat like infinity. The same negative infinity, you can give like a minus inf. It will treat like a minus infinity. Sir, what if I give in a different way? So the same infinity, if I give, say like capital INF, so it's working. Or like, so you can give all capitals and see whether it works or not. INF, you see, it's working, right? So anyway, it is working like infinity. So that's what you understood. Now, the most easiest thing is converting anything to a string. So till now, we have seen what are the limitations of converting from one to another data type. But if you're trying to convert anything to a string, there is no problem. So that's the beauty. So anything in any data type can be converted to a string. String is just like a characters, right? Just a representation. So it doesn't have any problem at all. That's why I like working with strings. Next, we will work on the string operations. But before that, till now we understood about the basic conversions. Now going for the next thing called as representations of integers. So only integers, not floating point values. Coming to the representation, so we can have like, decimal form. So decimal form, and we have like, binary, and we have like octal, and we have the last one, hexadecimal. Hexadecimal. What are these formats? How to work with it? If I can quickly see, you'll understand that. So first, I have a number. The moment the everything that we see till now are like the decimal numbers. So we have like base 10. Base 10 means 0 through 9, all characters, all integers can be used. So 0 to 9, there are 10 numbers. That's why it is called a decimal, 10 values. But if you want to convert that to a binary format, so there is something called as bin. Bin is a built-in function for converting anything to a binary. But did you see the binary format is like a string, but it is prepended with something called as 0b. So if you do that, yourself or anyway, you will understand the same. Okay, sir, if I just do bin, what will happen? It will throw an error. You should give some value. But what if I give 23.3? Can I convert a floating point to a binary? You don't know what to convert a floating point to. But what if you can convert a floating point to an integer and pass to it? Will it work? Yes. So now you understood about the limitations of this also. So similarly, to understand how these floating points are converted, you can understand this concept of binary representations. So there is some concept called as 2 to the power of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5, 6, like that. Any number can be represented in these terms. If I say 23, 23 can be represented like this. How? So 23 can be first represented in terms of 2. So first like this. Let me show this. You will understand in one step. So is 23 greater than 128 greater than 23? 0. 64 greater than this? 0. 32 greater than this? 0. 16 greater than this? No. Then 1. So 23 minus 16. You have like 3 and 4, 7. 7. Is 8 greater than 7? Yes. So 0. Is 4 greater? No. So we can place a 1. So from 7, if I remove 4, I get 3. So 2 means 1. 1. So like that, we can represent it. Now, if you add the positions at which the position is 1, 16, because 16 into 1 is 16. So at 8th position, it is 0, leave it, plus 4, plus 2, plus 1. If you combine all of them, you get the same number. If I now say bin of 23, you get the same answer. 0b is there, but after that, did you see? 1 0 1 1 1 1 0 1 1 1. You got it? In the same fashion, if I say bin of 9, you get the same answer. And one more interesting point. Will this bin work for negative values? Works. So there is nothing wrong in trying and testing. So if you go for an interview, they will try to test whether you have tested this kind of edge cases. Similarly, so if you have a binary value, then how to convert back to an integer? Using the int function only, but we should specify base equal to 0. If I don't specify that, it don't know what it is. If I say the same thing, int of same value, if I say int of, so 0b, we should say 0, it's not O, B, 1 0 1 1, then it cannot just convert it. But if you give like a base 0, then it understand that, hey, whatever is given input is like a binary form, then I need to convert to integer and then it will convert. So if you don't give 0b also fine, but if you say base 0, then it will understand like that. If you don't give like a base 0, then it will not understand that it is a decimal form. It will treat like an ordinary integer, decimal integer. So that is the importance that you need to understand. Next, one very weird option we have, I never used. If you feel like useful, you can use it. This is called as a bit length. Means for any number, decimal number, if when converting to decimal form, how many digits it will generate, that is its bit length. Means excluding this 0b, how many digits are there here? 1, 2, 3, 4, right? So 4 digits, that is its digital form. So sorry, bit length. So like that, this is one operation. Similarly, if you want to convert anything to octal format, so there is a built-in function called as octal. So we can use that to convert. And similarly, so there is one more thing. So if you want to convert back from octal back to decimals, as I told you, so like this, octal you can give or base 8. Octal is like base 8. So converting from integers to octal, octal back to decimal format, like that. Similarly, if you want to get to a hexadecimals, the same story again. So converting a decimal to hexadecimal, you have a built-in function called as hexa. You can use that. And if you want to convert back, you can use into function itself, but with base 16. That's a difference. So we can work with positive or negative values, but not floating point values. This is what you should be aware. And similarly, one last point, again, we will come back to this concept when you're going for string formatting. But if you want to convert anything to a string format, we can use this kind of string formatters. This is some concept called as string formatting. So means like, if you want to convert directly also, we can convert to a string. At the same time, this is another way to convert. So, so this concept is very interesting. You pass like a string, percentile hash 0, sorry, O, means it is octal format. It will convert like that. Or you can give like this. So percentile O. You don't give hash, then also it will convert. But the difference you understood, right? If you do like a hash, it will represent it as it is. If you don't give a hash, it will convert to a octal, but it is printed like this. It's not converting to 12, if you can observe carefully. So like that, if you want to do format, there are different ways of format. Format is another built-in function. Once we go to the string formatting, I will show you there. The same thing logic goes even if you work with like hexadecimals also. We're converting to a hexadecimal. What I showed there, the same things. And lastly, if you want to check, so for something, whether it is an integer or not, there is one more attribute. Observe, for ordinary integer, we cannot do directly dot. That's why I'm placing one brace around it. Observe carefully. Even for this or like bit length, these are like attributes, right? So we need to work like this. I placed a brace around it. So that's the difference. Here also, the same thing. Now here, observe carefully. It is 2.0 absolute value. So that's why it is saying, is it integer? True. But if you say 2.1, this is not absolute, right? So it's see, uh, so it has some decimal value after that. So that's why it is saying false. Even 1.99999, it is not like complete. That's why it says false. If sometimes, if you want to check these things, you can make use of it. Similarly, not only this, one last point before closing is about the Roman numbers. So Roman numbers are like, these are like, if you know, these are like not Roman numbers, like, Telugu numbers. So Telugu numbers, if you see here, you get the corresponding numbers actually. What are their numbers representing? So if you want to know more about these characters, how they are represented and others, so I have like different things. So this is kind of like a for loop. You will understand about it afterwards. This is called as a list. Means if you place anything in square braces, it's a list. For multiple values, I want to show in one shot, I am did like this. Generally, in English, we have like, so 1, 2, 3 symbols, right? So, so these were the symbols for this corresponding numbers. So if you want to see, this is how we do. So if you want to know more about these things, we can click on this to this link. So you can see about like, so open this. You can go to this link to see what are the different kinds of Unicode characters and how they work. So you can check for different kinds of characters. So different languages which all you want to do. So this is all about this concept. And lastly, after this type conversions and others, the last point is about the complex and the absolute. So to know further about this, we can work on the last thing, H, complex numbers dot ipynb. So I'm creating an IPython notebook because it's easy, right, to work with complex numbers. So till now we know that they are also part of the integer family, but slightly different. What is the difference? Means to understand, complex numbers are like a combination of real and imaginary value. Real and imaginary value. What is this real and imaginary concept means? So, and also some languages use J, some languages use I to represent the imaginary part. In Python, we are using J for representing the imaginary part. Assume that I have an ordinary number. So if I do like number 1 equal to 2, it says it's of type integer and it works. But what if I have number 1 is equal to 2 plus 3? It's an ordinary addition. It will add and give an integer. But if I say like I I have a value which is 2.3j, 3j, then it is treats it like a complex value. Complex, the moment it encounters a j, so imaginary part, it will treat like a complex value. I can have like a negative parts also, plus, minus, anything. Or like I can have even a 0j. When you have a 0j, this is one of the entry question. If you have a 0j, will it treat it like an integer or like a complex? Even if you have a 0j, it is treated like a complex because it has a 0j is different from 0. So I'm saying like 0 is not equal to 0j. Oh, sorry, I did like, oh, okay. 0j is not equal to 0. This is what you should understand. And similarly, when users are defining, so we can make like 4j or any number followed by this j. But if you do like any other combination, it will throw an error. Means like if I say like j4, will it work? It will treat it like a variable. You don't know what it is. If we assign some value to this j4 or something, then it works. So it's like an ordinary variable. But if I do like 4 and j, that's where it understands. What if, sir, I write like 4 into j? Then also it is error. If you want to do individually, you should say 4 into 1j. So that's where it makes sense. Similarly, if you write something, the value of j, and then print 4 into j, then it says. So now the point you need to understand is that we cannot represent in all these kinds of formats. Now, this is how you work with complex. Similarly, what if you want to create a complex number of your own? For that, there is something called as complex built-in function. Using that, we can create a complex function. You give two values, we can create it. So similarly, if you want to check whether two values are equal or not, just now I showed about the equivalence operator, right? We can use that. Whether 4 is equal to 4, yes. 4 equal to 4.3, no. 4 equal to 4j, no. So like that. Similarly, so this is another thing I'm giving. See here, 3 plus 4j is not equal to 4j plus 3 because so apples will be compared to apples, oranges will be oranges, like that. There is a saying like that. So real values will be compared, imaginary values will be compared.